First Spin.
Welcome to First Spin, a show where I learn how to use a Parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted the help of two experts.
Two hacker experts.
Hacker experts. Extraordinaire.
Yeah.
Today is like...
Yeah.
This is... Let me explain something. This is the third time we have recorded this particular podcast. This particular episode.
We weren't sure we were going to be able to record it at all because Roy is very sick this week.
Oh, yeah.
He's been hacking, but not in his usual way.
Right.
He's been hacking up a lung.
Right.
Our $600 main mixer here in the recording studio died today.
Correct.
And I don't know what we're going to do about that, but it's a really bad thing. And so right now I've stolen a bunch of like guitar cables and an old Behringer mixer and absolute crap, and we're going in through a single microphone sitting between Addie and I and the line in of the computer.
Correct.
Which is completely inappropriate and wrong, and I feel horrible about even doing it this way, but we got to record the show. It's Tuesday morning.
The show must go on.
Addie,
and we're sorry if it sounds a little rehearsed. It is our third time.
Because the recorder also keeps shutting off at the 30-minute mark for no apparent reason.
Right.
So, yeah, we're going to stumble through this, and we're going to cut it off a little early this time. So,
right.
Okay, it's 2 in the morning. Addie needs to be at work in 3 hours. So we're just going to...
dedication.
We're just going to get through this.
Dedication to the noob.
Yeah, thanks for listening, everyone. We hope it's easier for you to hear it than it was for us to make it.
Right.
Yeah.
Okay, so we have gone through the 5-position switch. We have gone through the ping sensor and the RC servo. Correcto mundo?
Mm-hmm.
Correct. So today I thought we'd go into the GPS antenna, GPS module.
Parallax PMB 648 GPS module.
Correct. And it is this super cute little 1-inch by 1-inch thing that does pretty amazing stuff. It gets these signals from, 20 satellites?
Up to 20.
Up to 20.
I've never seen it do more than 10 at a time.
Oh.
Yeah.
And that was in, Wyoming.
Sorry.
Yeah, quit talking over me, Roy. You know what I'm going to say already.
There's a few places on the Earth where you could see up to maybe 11 or 12 at one time of the satellites, but the satellites are all orbiting the Earth around all the different, geosynchronous orbits going in all different directions. So at any one given spot on the Earth, you're only ever going to see maybe 9, 10 at any one time.
Okay.
And most I saw...
That's only if you're not down in a valley or something.
Right.
Most I saw was on the way out to Parallax Robotics Expo. A couple months ago, we drove out there. And on the Great Plains heading up into the Sierra Nevadas, I think I saw 9 and 10 satellites at a time pretty consistently there.
Oh, cool.
Yeah.
It's like they're all feeding into this one little square, telling you where you are. I like it. Very cool.
Well, luckily for all of us, these little GPS receiver modules exist, and they can do all the hard work of translating the information from the satellites and triangulating and figuring out where you are and producing a single output of all the data.
Right. So in looking at this GPS module, there's a whole bunch of wires coming out from one.
There's 6.
That's a whole bunch compared to the ping with its 3 little prongs. So the thing with this, and let me back up just a little bit. If you haven't already checked out the learn.parallax.com website with their kickstarts, please do. It's an extremely good resource. So the Kickstart program, I guess, is a whole bunch of, it's got a web page for each module.
Yeah, a bunch of tutorials for each of their various modules and how to interface with them.
Correct.
To the basic stamp or propeller or even an Arduino.
Correct. So it essentially, that's where I started from with this GPS module. And so we'll go through that a little bit, but then kind of work off of that. It's a Kickstart after all. And so the wires that you actually need to connect, there's like Roy said, there's 6 of them, which I think is a bajillion. But the red one goes to VCC, the black one goes to ground, and then the yellow one goes to whatever your serial terminal is talking to.
The pin on your microcontroller.
Right, the pin. I call it a signal pin, but
right.
Technically it's just the GPS talking to your computer or your propeller. So those are the actual only 3 that you need, and just be careful not to connect these based on the color of the wire and not the label of the markings on the PCB, because the PCB labels do not correspond to the color, the wires that are coming from that particular spot. So just be careful of that. And yeah. So then I had a question. Quick question. There's a whole bunch of other wires, right? So what are these other wires for?
Okay, so we already covered the yellow wire is the one that you hook up to your pin, and that's actually a TTL transmit from the module to the propeller or to your microcontroller.
Okay.
The blue wire right next to it is actually the TTL receive for the module, so you could actually send it a serial byte or command, and I think it has actually a couple of advanced commands you can send it to turn it into different modes.
Okay.
The other 2 wires that you haven't used are the gray and the green wire, and those are RS-232 signal level wires.
Okay.
So they're basically a duplicate of the TTL signal, but in RS-232 land, which is, different timing, and it actually uses plus and minus 12 volts or 9 volts, depending on which RS-232 you're connecting to. And it's just this module has it as an optional ability to be able to use RS-232. So you could hook it up to some other devices that might require RS-232 and don't have a TTL signal.
And that's just serial, right?
Yeah, RS-232 is a standard serial mechanism. A lot of computers up until recently, when they got replaced by USB, used to have serial ports on them.
Okay.
And those serial ports are RS-232 serial.
Gotcha. And then I know, so there's VCC I see here, but then I know there's like VDD and VSS. Do you guys have like a brilliant way for knowing what in the world is what?
Yeah.
Well, VSS is always ground.
Okay.
Right? And then VCC and VDD let's back up a step. It used to just be VDD or V for voltage, and that was when it was 5 volts for everything.
Okay.
Yeah.
For the most part.
There's VDD, and then they added the CMOS stuff, and it became VDD or VCC. Right. And those are the only 2 that Parallax uses on their boards, I think.
I see.
Right. Occasionally you'll also see VN, which is like the input voltage from like your battery or your wall wart.
Yeah.
So wait a minute. So VDD is the 5 volts, and then VCC is the 3.3.
Yeah, and VIN is either the power coming in from the USB, or the power coming in from the battery, or the power coming in from the power supply.
Okay.
Right.
Okay.
So it's going to be whatever high voltage your input is. It might be 12, it might be 9,
Gotcha.
It might be 6. It's
Gotcha.
And that's before the onboard regulation, so you kind of have to treat it as an unknown.
Right.
Okay.
And just as a reminder, the VDD and VCC, as far as Parallax boards for the basic stamp and for the propeller and the prop BOE, which we're using, the VDD is 5 volts and VCC is 3.3 volts. On some other boards, the VCC might be a lower voltage because some CMOS devices can run at like 2.5 or 1.8.
Okay.
So you should look up on the particular board's
Okay.
Data sheet or manual for what the voltages are. But
okay.
For Parallax, it's standard.
Okay. That sounds good. And then I realized that we didn't actually say what the GPS module can tell you, but there's actually quite a bit of information. There's latitude, longitude, and then you can also get speed, heading, altitude, and you can even get time, date and time in UTC. So very cool. Like there's quite a bit of information. Now the code on Kickstart only shows the latitude and longitude on your serial terminal, but we'll show. Well, I'll talk about how we can get the other information. Okay.
Yeah, because the module they provide lets you get at that other information.
Right. So on the Kickstart page, there's this download propeller spin code for the PMB 648 GPS. So when you click on that, you'll see a whole bunch of files that need to be in your prop tool library or your Brad spin tool folder. And those are just like different objects and such. So I mean, we can go into that if that's okay with you guys.
Yep, no problem.
Yeah. Yep. Okay. So the object, there's the debug, which is the full duplex serial plus, which interfaces with the serial terminal, correct? Okay.
Correct.
And then the GPS, that's GPS underscore float underscore light. And that, I think, is like the big cojones, the big dude on campus for the GPS. So what this
is doing is it's taking the GPS module itself is just outputting a string, which is in the NMEA form. It's a standard string format which contains all of the data in, a whole bunch of numbers and letters strung together with commas and whatnot, and it's parsing that and giving you out the individual pieces of data in human readable form.
Okay.
So you get each of the longitude and latitude and time and date and all that.
Okay.
By using this object.
Okay, and the NMEA string, that's all the GPSs talk in that manner?
Yeah, pretty much all GPS modules use the NMEA standard format for their strings. Some of them will have more or less of the data available.
Okay.
But the format of the string is standard so that if you read it in the appropriate way, you'll always get whatever data is in there will always come out appropriately.
Okay. And then FS goes to float string, which I don't...
What that is a piece of code that will allow you to take a floating point number, which we're going to get out of the GPS code, and turn it into a string so that you can print it on the serial terminal.
Oh, okay. Handy.
That's all it does.
Very
Pretty
handy.
simple.
Right. Okay, so then we go to the con section. We know clock mode. We know X and freak. And let's see. Then we have the pub init. Initiate. Init. Little frogs everywhere. It's a summer night.
They just happen to name their particular function
init. Right. With the local variable fv.
You got to initialize.
Correct.
And just as a, this is the only function in this spin file, so that's the one that will run because it's the only one.
Yeah, that makes sense. Right. And then we do debug.start with the RxTX or TXRX. I forget the
TXRX order. And then the mode. And
TXRX then mode and then baud rate. And then for those working with serial terminals, always remember to make sure your baud rate on your serial terminal window is the same as what's in your code. Otherwise, when you run the stuff, you'll get like random smattering of letters and such.
Yeah, you get garbage and
right.
Sometimes you just don't get anything at all. It just depends on the settings.
Right. And then
make sure you use a good clock source too.
Oh.
Right.
The RC time isn't going to work.
Okay.
Yeah, if you're using the RC fast or RC slow modes, it's going too slow and it's not a stable speed so that you'll have trouble keeping a consistent baud rate.
Yeah, the drift is wide enough that it'll actually drift more than a clock pulse apart. So you'll start to get garbage coming across your serial line.
I see.
Okay. It's very embarrassing. It's a bit like forgetting to zip up your fly.
I see. Thanks for that. So, everyone, zip up your fly. Make sure your baud rate's the same. Okay, so, and then the debug.string, and sometimes if the serial terminal object that you're using is labeled term or labeled anything, terminal, whatever, it'll be, instead of debug.start, it'll be like term.start. So, just letting you know. And then debug.string, it's sending a string saying, hey, I'm reading the GPS. And then it's waiting about 2 seconds. And then it's starting the GPS object with GPS.initialize or init.
Init.
And then it goes into debug.string string, comma 16, comma 1. And I'm going to gander a guess, if that is even a word or phrase, that has to do with the Ascii tables.
Well, a little bit. The Parallax serial terminal has assigned special meaning to the characters from 0 to 16, which are below the visible characters, because space starts at 32, and then you keep going up.
And those first 16 characters, I mean, they've always been control codes of some sort or another.
Oh, right.
And different systems have used them in different ways. This is just how Parallax uses them.
I see.
They've always been control codes, though.
I see.
And
Okay.
and some of the ones that they have are standard, like there's a tab at 9, and
13 carriage
is
return.
carriage return,
Yep.
and stuff like that. But there's a few extra ones that they put in, and 16 happens to be to clear the screen, so it'll clear the Parallax serial terminal window. And then 1 is to home the cursor, which puts it back up at the top corner.
Okay.
Right.
And then for those of you who are just starting to work with serial terminals, if you notice like the code sending random numbers, like 16, 32, whatever, then check an Ascii table to see like what that represents. Because usually when I see random numbers, I go to the Ascii table and I'm like, oh, they're trying to put a space here. I get it.
Once you wrap your head around the way that Ascii works, you really get a better feel for how computers work in general. Because once you're familiar with that table, you've looked under the covers and you know what's down there, and it all makes a lot more sense.
Gotcha.
Right.
Okay. So then, So it clears the screen, and then it goes back to the beginning, and then fs dot set precision 7. I take it the fs is the float to string, so it's setting 7 digits of precision.
Yeah. So when it converts a float to a string, it'll only do 7 digits of precision in that conversion.
Gotcha. And then we take the local variable, and then we set that to gbs dot float underscore latitude underscore degree. And that float underscore latitude underscore degree is, you can actually find that as a function in the
GPS float light.
Right, GPS float light, which is the main GPS object. And that's important. And
now
we'll
with 50% less calories.
What? You're just stop distracting me. Okay, so it says, all right, we're going to set this variable to this float latitude, this latitude. If the number does not equal float nan.
So float nan is not a number. It's just a special value that means that the floating point number is an invalid number.
Okay, so
it's a double negative.
So if the latitude does not equal not a number, does not equal not a number. Okay, what? Okay, well, I'll just does not equal not a number.
It's a Boolean hootenanny.
I know. Then send the string fs dot float to string parentheses fv. So
yeah, so what that's doing is it's taking your floating point value that you got back from the GPS module, and it's passing it into the float to string converter, turning it into a string, and then that's getting passed into the debug stir function, which prints the string out over to the serial terminal.
Oh, so it's okay, I see. Latitude, making it a string, sending that string to the terminal. Right. Otherwise, if the float value is not a number, then
it just prints out some dashes.
Right. You do dash dash dash.
Right.
So okay. And then that pretty much repeats itself with the float longitude degree. If longitude does not equal not a number, then we print
that out. Yeah,
right.
It just does this exact
and then
same
we
thing
wait count. Right.
So it's just basically printing out the latitude, comma, longitude.
Right.
And before the GPS module's ready, it'll just print out the dashes. But once it's locked onto the GPSs, it'll print out the two numbers over and over again with a small delay between them.
Okay. Right. So, and I think we've taken this around the house to see like how it changes, and it actually changes quite a bit. So that was
inside the house, you're probably going to get errors just because you're not talking to too many satellites.
I see.
So you'll get a pretty wide variance because when there's only a few satellites, the accuracy is very low.
I see.
So it's going to just sort of vary all over the place. But if you were outside, like taking a walk, you could write down the longitude and latitude like every few seconds and plot it out, and you would actually see it draw a pretty accurate path of your walk.
That works.
And you could calculate your speed, which is, what it can do internally as well.
Good point.
That's how it works.
Very good point. So, when I was looking at this, I didn't understand pretty much all of it.
Sorry.
So,
another piece of my lung.
That's fine. So when I was looking at this, I didn't understand most, of it. I just said, oh, look, there's float latitude degree. Nice. I actually then decided that I wanted more information from the GPS. So like I said before, it's got a speed, heading, altitude, location, as well as time. So when I looked at this, I was like, it kind of looks modular. So why don't I see how I can get information from the object to put in? So when you look,
for you, GPS Float Light actually has functions for all those things in it.
Right. So when I looked at the GPS Float Light, the object, I was like, oh, la-di-da, wait a minute. I see float _ latitude _ degree. And then a light bulb clicked on my head, and I was like, oh, GPS.float _ latitude _ degree gives you that number.
The light's actually dim in the house when this happens, by the way.
It's true. I sometimes cause a little flicker.
She consumes extra energy to process these.
So all I did pretty much for my own code was copy paste. So I would look at the functions that were available in the object, and I would say, oh yes, I actually do want speed over ground, so I'd copy paste float _ speed over ground into the code, and then just do kind of a chunka of modular code.
Right.
Now the one thing,
and day and year and
right,
altitude and stuff like that.
Right. And the one thing that I had to learn also was that if, say, for instance, I'm trying to get the date and the time, those are longs. And if I tried to debug.string those, it wouldn't work.
Right, because it's a long instead of a float, and the float is converting, the code tries to convert a float to a string, and you just get the wrong number.
Right. So, essentially, whenever I saw that there was a float, like float _ altitude, float _ speed, whatever, then the debug string would be debug.str.fs.float to string, blah, 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 like what we've already talked about. But if it was a long, so like long _ month, long _ day, long _ second, whatever, then I would change the debug line to debug.decimal or DEC, and then just the exact value. I didn't have to put it through any float to string.
Right. The other thing that you didn't have to do is when you're getting the long values back, you don't have to compare them with the float not a number, because they'll never equal that float not a number, because that's only for float values. So you can just print the DEC GPS long day, long year, whatever.
I see. Well, see, and that's how you can tell I didn't know, because my code shows that if float equals not a number. I was like, I don't think I'm going to change it because I have no idea what it means.
Well, it'd have to work out for you because the values would never equal that coming out of the long.
Right.
The long would never equal that, so it'll always print them. Because
so it always worked.
Number. Yeah.
Right. So that is actually essentially is how it works. And with that, so I'll paste the link for the code that I worked on, but also the code that I worked from, and I essentially was able to get all the information I wanted. So very cool, and it's also a good experience to actually look into the object and get information out from it.
If you're on one of these other Kickstart pages, you can learn by just using the code that they show, but you can also go look in the module and see if there's other functions you might call and get data from.
Right.
All right, so it sounds like you've had some fun playing with the GPS module. Have you had any time this week to think about David's questions from last week?
Well, I actually had a pretty
2 weeks
busy.
ago, I guess.
Yeah, I actually had a pretty busy work week, unfortunately, reading EKGs no less, but not really thinking about how to actually get them. But I thought it was interesting that we should potentially include, I think, the latest module that Parallax has made.
David asked us if Addie had any bright ideas for an inexpensive way to create an EKG using the prop or whatever.
Right.
Of course, Addie's not an analog expert, so this is probably over her head a bit, and we'll probably want some feedback from you guys. But what were you saying, Addie?
Oh, I was just interested in mentioning that Parallax has this cool new sensor. It's a polar heart rate sensor, something like that, like
receiver.
Heart rate receiver.
So the Polar is a company that makes heart rate monitor devices that you can wear around like a strap around your chest with a sensor.
Okay.
And it actually sends out a little wireless signal.
Okay.
And a lot of like exercise equipment at 24-hour fitness or whatever has a ability to read those heart rate meters and show you your heart rate while you're exercising. Well, Parallax now has a module that can link up to those heart rate meters, and you can hook it up to your propeller or basic stamp and read the heart rate, and it gives you a pulse for each heartbeat.
Gotcha. Very cool. Super cool. So I think that's a simple signal. Right. And I think that'd be something important to incorporate into the EKG, which we've had a friend make an EKG before out of an oscilloscope and like 3 probes, which was super cool. Although his heart rate was a little odd. I didn't want to tell him, but like if I can get over my fear of oscilloscopes and like probes and such, then I think I could theoretically come up with some sort of oscilloscope. Or some sort of EKG, which is an electrocardiogram, which shows the electrical activity of the heart in greater detail than
There's other ways
just
to do that
rate.
too, and I'm sure some of our listeners probably have ideas. They're all very smart. So if you guys have any ideas of how Addie might approach this problem of an EKG, you guys can send them to feedback@tymkrs.com or send them directly on Twitter over to Addie @ATDIY. And I'm sure somebody will probably suggest fast Fourier transforms as one potential starting point, just to get it right into the digital domain out of the gate. I'd love to hear your guys' ideas. We'll definitely talk about them on the show if you send over those ideas. That's all the time we have for this week. We're going to cut off just a minute early here. Thank you everyone for listening. We've had a terrible day. We need a giant internet hug. Yes. So if internet, you could give us a nice hug, that would probably make us feel better. Thank you.
And hopefully next week will be better.
Correct.
We'll see. All right, that's it for us for this week. We'll see you guys next Tuesday at firstspin.tv.
Bye.
See ya.